Hi guys, I'm going to go over today's lesson. So today is October the 21st. So we started off our day with our Go Noodle movie, or not movie, our Go Noodle video, and we did our morning movement with that. Then we read a story called Penguin Problems, and then we got right in at 8 o'clock. Our times were adjusted today because we had benchmark and we had our writing benchmark test this morning. So in Google Classroom, under classwork, the benchmark, we started the first part of it. So we worked on pages 2 and pages 3. So students have up here their introduction. They have spaces here where they type in their 3 reasons and their conclusion. And then tomorrow we will go fill in page 5 and 6 if needed, so that they can write their final there and have it officially published. So we did that from 8 to 10. Then after that, we got into math. So everything kind of just shifted. And so in math today, we were introduced to the hundredths. And we started talking off, connecting these ideas that we've talked about with money. And so it says, we have a coin that shows tenths. Do you know what it is? And that's our dime. So there's the front and the back of the dime. And it says, how can dimes show tenths? 10 dimes is equal to 1 whole, or $1. So each of these is a tenth, or each dime can be written as 0.1. Remember, we call the first place to the right of the decimal point the tenths column. We read the decimal point by saying and. So we practice reading these: 5 tenths, 4 tenths, 7 tenths, 2 tenths, 14 and 8 tenths. So here, this one is different because before, we don't need to say 0 and 5 tenths. We can just say 5 tenths. We don't have to say the 0. It doesn't have a value. But now that we have a value to the left, we can say 14 and, when I get to the decimal point, I say and, 8 tenths. 8 and 1 tenth, 1 and 6 tenths, 11 and 9 tenths, 2 and 3 tenths. So then we moved in, so that wrapped us up with our tenths. Then we moved into hundredths. And so we reviewed, we've got 2 tenths there. So we can write that as 0.2. This one, we've got 7 tenths, 0.7. Here we've got 9 tenths, 0.9. And so instead of these red dots, we can replace it with coins. So we just learned that we can use dimes to replace. Because remember, if we had all 10 of these, that would be equal to 1 whole. And so here, each dime is worth 1 tenth, or 0.1. Then we can break it down even further. We know that we can take our dime and we can be taking it one step further by breaking it into another 10 parts, and that one is with a penny. So 1 dime is equal to 10 pennies. So if we think about what fraction of a whole, think about $1 as our whole. How many pennies does it take to make that dollar? That would be 100 pennies. So 1 penny is 1 out of 100. 1/100th of the whole, because there are 100 pennies in each of the dollar, or in each dollar. So we want to write that now as a decimal, and that's where we get introduced to the next door neighbor. So here we've got our wholes, our decimal point, our tenths. Our hundredths are going to go right next door. So here, I like this representation. We put this in our notebook. 1 whole, think of it as $1. The tenths goes right here, and the hundredths goes right here. So 1, 10, and a penny. And this helps. This is a great visual as well because it shows that as you move to the left, your values get larger. And as you move to the right, your values get less and less and less. We know that a penny is much smaller, has a much smaller value than the dime and the dollar. So hundredths can be represented with a model that has 100 squares in it. So we will see this model probably 5,000 times. We'll do lots of practice with it. And this is how we show our fractions and decimals when we've got 100. So each one of these is a penny, you could think of it, or that 1/100th. If we look at this square, we see that some of them are shaded. There's 18 shaded. So the fraction would be 1800ths, or the decimal would be 0.18. And the way that we read that is 1800ths. Let me bring up. So if you look on the place value chart, you have your ones, your decimal point, your tenths, and your hundredths. So in this one that we had here, we had 18 of them shaded out of 100. So that's like having 18 hundredths. Well, we know that in a place value chart, there's rules. And one of the rules is that you can only have one digit per column. So within this, I call it like think of it like a parking spot. Only one car or only one digit can park in that one spot. So we learned several years ago that if we have two digits there, we have to regroup. So we're going to take this 1 and we're going to regroup it next door to the tenths. And that's where you get 0.18. Because once the 1 leaves and regroups, all you're left with is the 8. So this 0.18, 1800ths, is what we get. And that's why it's like it is. So whenever we read the numbers, this 0 is in the ones place, this 1 is in the tenths place, this 8 is in the hundredths place. The way that we read it is when we've got a decimal here, we say the whole number. So we say 18. And then we look, this is the very last digit. We look at the place that it's in. So this is 18 hundredths, okay? If we only had this, the last digit is in the tenths place, so then we would say 1/10. So whatever that last digit's, wherever that last digit's at, you look above. This one is the hundredths. So we say 1800ths. If it's tenths is the last place, then we say tenths. Alrighty. This one, we have 27 shaded in out of 100. So that's 27 hundredths, or 27 hundredths written like that as a decimal. Here, 30. And now here, this one is a little bit different because this one, if you notice, each one of these, if we go straight down, that's a tenth. And here's another one, and here's another one. So we know about equivalent fractions. So 1/10 is equal to 10 hundredths. We can compare those and see that those two things are equal. Let me show you when I write it out. So we can say that 1/10 is equal to 10 hundredths. Okay, we can cross multiply. 1 times 100 is 100. 10 times 10 is 100. 100 is equal to 100. So therefore, 1/10 is equal to 10 hundredths. So every time that I have 10 of these, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, That's the same as saying 1/10. So this is 1/10, 2/10, 3/10. So when you write it, you can either write 0 and then the 30 hundredths, or you can remove that 0 because all it's saying is that we don't have any hundredths. We have 3/10. And again, I can say that because those are equivalent. They're the same. Here, 44 hundredths, 44. And you can notice, look at this 4 right here. This 4 right here is in the tenths place. And there's 1, 2, 3, 4 that are going, those lines that are going all the way straight down. So that's where my 4/10 comes from. And then you've got extra 1, 2, 3, 4 goes in the hundredths. 44 hundredths. Here we've got 73 hundredths written as 0.73. And here we've got 7 hundredths. Now here, look at the 0 in the tenths place. There's none of them that go all the way straight down. So we don't have any tenths. That's why the 0 is in the tenths place. And this 7 comes from the parts here out of 100. Here we've got 5 hundredths. Again, there's no tenth, so we put that 0. We have 5 hundredths, 5 parts out of 100. All right, and then remember, the first decimal place is the tenth. So if we look straight over, we have the tenths. And the second place right after is our hundredths. Okay, and some people get confused because it sounds like if you say hundreds, it sounds like 100, and 100 we know is much larger than 10. But you have to remember, we're not talking about whole numbers. We're talking about these fractions, these decimals. These are not wholes. They're parts of wholes. And so if you picture, if you have a cake, 2 cakes, and one of the cakes you cut into 10 parts, and one of the cakes you cut into 100 equal parts, the one that has 100 equal parts is going to be a lot smaller than the one that has the 10 parts. So as we get to the right, we get smaller. All right, then we went to Seesaw. And under the activities, we had an assignment where we practiced that. And this assignment is having you show the model, the decimal, and the fraction. So just like we just saw lots of examples of, that's practicing that. So that needs to be turned in today. Then in reading today, we continued where we left off. All right, there we go. All right, so we continued where we left off. We did the third one, which is on description. And so this was talking about Grandma's house. It said, my grandma's house is cozy and dim. She has many cool things to read, including magazines and old books from my mom's childhood. She loves to cook for us and make us things from Germany. And so it's repeatedly describing things that what it's like at grandma's house. So we said that this is this text structure is description. And so students, we took something, so I took school, and students shared some ideas of how you would describe school. So on this page 4, that needs to be filled out. And they are using whatever the thing is that they're describing goes in the middle, and then the descriptions go on the outside. And then let me draft this. And then students had their, right here, name that text structure. The next 2 pages where they're recording and deciding the text structure on that. Alrighty. Make sure I didn't forget anything. All right, then we went to lunch and recess. All right, afterwards, when we came back, we just had time for science. So I told them we would do science today, and then tomorrow we would do social studies for when we come back at 12:05. So today, students in science, they continued working on their comic that we've been creating. So we sang our weathering, erosion, and deposition song. So it goes like this. Weathering breaks it, erosion takes it, and when the motion stops, deposition drops. So we sing that a few times to help us remember that whenever you are talking about the process of weathering, you're talking about the breaking down of rocks, and you will have those pieces of sediment. They will be moved from one place to another, either by wind, water, ice. Something's going to happen that's going to cause them naturally to move. That part is erosion, that take it part. And then deposition is when those pieces, they finally stop moving. Maybe they start building up and creating a new landmass somewhere else. Wherever they're deposited, wherever they're dropped, that's deposition. And so students worked on their comic that is describing each of those processes. And that was the rest of our day. So let me know if you have any questions. Thank you.